Alright. For this first one, it's simple enough. The only correct one is C. Let's do D. So 2 pi f, what's f? 1 over t, right? 2 pi over t equals root L over G. So root L, small l maps to big L, G becomes L over t squared, because you're dividing it, you flip it, so t squared over L. The L's cancel out. You're left with 2 pi over t equals t. So it's wrong, they're the same. Okay. Next question. A bicyclist makes a trip that consists of 3 parts, each in the same direction due north along a straight road. During the first part, she rides for 22 minutes at 7.2 meters a second. During the second part, she rides at 36 minutes for 5.1, and then 8 minutes at 13. How far has the bicyclist traveled during the entire trip? How far has she traveled? Well, you have to convert first the minutes to seconds, and then you multiply that by the speed, right? That'll give you, so she traveled at 7.2 meters per second for 22 minutes. So that's the first part. And the second part is 36 minutes at 5.1 meters a second. And the third part is 8 minutes at 30 meters per second. And you add those all up for the total distance. The second one is, what is her average velocity for the trip? You can't simply add up the 3 velocities and divide them by 3. That wouldn't be correct, because each velocity is traveled at for a different period of time, right? This one's for 22 minutes, this one's for 36 minutes, whatever. The easy solution is speed equals distance over time. Well, what's the time? 22 minutes and 36 minutes and 8 minutes. Convert them to seconds though. And the distance is, you found it in part A. So that's your answer for that one. The Zarm Tower in Bremen contains the world's longest vertical vacuum tube, 110 meters. A sample is dropped from its top, and after it reaches the bottom, it is taken horizontally further 20 meters. The free fall acceleration in Bremen is 9.82 meters per second squared. Find the total displacement of the sample. Okay, so what's the distance? The distance would be 130, because it's 110 plus 20. Right, but we're looking for the displacement, which is the difference between the original position and its new position. And this is a simple Pythagoras theorem, 110 squared plus 20 squared square rooted. And that's about 112. Okay. How much time it took for it to drop? Okay. So what do we know? We know gravity is 9.82, or maybe negative, whatever. And we know it's traveled 110, so we have d. The equation we'll use is the distance one. D equals VIT plus half AT squared. We've got D. D is negative 110, because remember we've traveled 100 meters below the origin point. The initial velocity is 0 times t, so just 0, plus half AT squared. Half A, what's A? Negative 9.82 t squared, and we're looking for t. So t equals 220 over 9.82 square rooted. Right? Because you multiply both sides by 2, you divide both sides by 9.82, and then to get rid of the t squared, you square root it. Okay? And putting that in my calculator, it's about 4.73. So let's note that, 4.73. Maybe it'll be useful for the next part. What's the impact velocity? The impact velocity, so it was useful. We need the impact velocity at this time. The impact velocity will be when the ball has reached 110 meters, right? What formula should we use? We're looking for velocity. The easy one is v equals at, or actually it's delta v, so it's the change in velocity. The initial velocity is 0, so the final velocity is simply at. What's a? Negative 9.82. And what's t? 4.73. So what's that equal to? Which is equal to about negative 46.45 meters per second. It's negative because it's traveling downwards, or you could say it's positive, it doesn't really matter. And what's the direction? Because velocity is a vector, the direction is straight down. A car is traveling to the left, which is the negative direction. The direction of travel remains the same throughout this problem. The car's initial speed is 22.3 meters per second, and during a 4.64 second interval, it changes to a final speed of 29.5 or 15.2 meters per second. In each case, find the acceleration, magnitude, and algebraic sign. Alright, so what we'll do, think of the formulas. What do we have? We have the initial velocity, the final velocity, so it should be obvious we'll use delta V equals AT. What's the final velocity? Let's expand it. Final velocity minus initial velocity equals AT. And we're looking for A, and we have the rest. A equals, just rearranging, Vf minus Vi over T. So what's the initial velocity? It's 22.3. The final velocity is a choice between this one and this one. And the time is the 4.64 second interval. So A equals, what's acceleration? So the final velocity is 29.5 or 15.2 minus the initial 22.3 over 4.64. So in the first case, if we use 29.5, we'll end up with A equals negative 1.55 meters per second squared. What does this mean? The acceleration is it means the car is speeding up in the negative direction. That's what it means. We have 1.55, so every second the car speeds up by 1.55 meters, and it's increasing speed in the negative direction. And normally it's a bit hard to wrap your head around. Normally you'd say if something has a negative acceleration, that means it's slowing down, right? But because we specifically in this question we describe the car as going left in the negative direction, we describe this as accelerating in the negative direction. And this makes sense because the final velocity was 29.5, the initial was 22.3, so we've increased our speed. So acceleration is going to be greater. How about the other one, 15.2? If we use 15.2 instead, we'll end up with a positive acceleration of 1.53. What does this mean? This means that we are in the negative direction, we are slowing down. So that means we're speeding up in the positive direction. Okay, try to wrap your head around it. We're speeding up in the positive direction, or we're slowing down in the negative direction. Okay, that's the answer. Always comes back to the formulas. Okay, for this one, a cheetah is hunting its prey. It's such a poorly worded question. Starting from rest, it reaches the prey with a constant acceleration of 4.1 seconds, and the prey moves along with a constant velocity of 9.6. What's the acceleration the cheetah had to have to reach the prey? Okay, so what do we know? We know the prey is moving at 9.6 meters, so that's the velocity of the prey. And we know it took the cheetah 4.1 seconds to reach the prey. So from this we can do something very simple. We can determine how far along the prey has traveled. It's just 9.6 times 4.1. And that's 39.36. That's the distance the cheetah had to have traveled. And we want to find the acceleration using that. We're looking for the acceleration. We can use delta V equals AT, but then we need the final velocity, which we don't have. Let's instead just use D equals VIT plus half AT squared. Because we're looking for the acceleration, we have it already. We have the time, we have the distance, we have everything we need. So what's the distance? We just found it out, 39.36 equals, what's the initial velocity of the cheetah? It's 0 times t, that just becomes 0, plus half a t squared, and we're looking for a. So what does t equal to? What does a equal to? A equals 2 times 39.36 divided by t squared. So 2 times 39.36 equals 78.72 over t squared. What was t? 4.1, so 4.1 squared and that equals 4.68 meters per second squared. That's acceleration. And that's the answer. Easy as that. Okay. The left ventricle of the heart accelerates blood from rest to a velocity of 28.9 centimeters per second. The displacement of the blood during the acceleration is 2.84 centimeters. Determine this acceleration. What do we have? We have the initial velocity at rest 0. We have the final velocity, and we've also got the displacement. Which formula should we use? We'll use the weed one. So Vf, the final velocity squared, equals the initial velocity squared plus 2ad. We're looking for the acceleration. We've got everything else. Let me scroll down. So the final velocity was 28.9 centimeters squared. We square it. The initial velocity was 0. That's squared plus 2 times the acceleration. That's what we're looking for. Times the distance, which was 2.84. What's the acceleration? The acceleration is, so we've got on the left hand side 28.9 squared. We have to divide that by 2, and we have to divide it as well by 2.84. So if we divide it by 2, that's 417. If we divide that by 2.84, so the acceleration equals 147 meters per second squared. So incredibly quick acceleration. Part B. What was part B? How much time does blood take to reach its final velocity? So we're looking for the time. We're looking for time this time. What formula should we use? Let's use delta V equals AT. The final velocity minus the initial velocity equals AT. The final velocity was what? It was 28.9. The initial is 0. And that equals the acceleration 147 times t. T equals 28.9 over 147, which is about 0.197 seconds. So what does this mean? This is pretty much 0.2 seconds. What happens in 0.2 seconds? That's how long it takes it to reach the velocity of 28.9 meters per second, given that it accelerates at 147 meters per second. So imagine that in just 1 second, it'll have reached a velocity of 147 meters per second. Interesting. That's that question done. Okay, next one. A car is traveling at 20 meters per second squared, and the driver sees a traffic light turn red. After 0.53 seconds, the reaction time, the driver applies the brakes, and the car decelerates at 7 meters per second squared. What's the stopping distance of the car is measured from the point where the driver first sees the red light. Okay, so you can imagine the driver sees the red light. It takes him about half a second to react, and then he spams the brakes. We've got the initial velocity at 20 meters per second squared. We've also got the acceleration at 7 meters per second squared. How about, do we have anything else? We have the final velocity. The final velocity is 0. That's when he stopped at the red light. First, let's calculate the thing before the reaction time. So he traveled how long in the reaction time before he pressed the brakes? He traveled 0.53 times 20, right? So he traveled at 20 meters a second for half a second. Okay? So that's the first part. What about the second part? We've got the, I told you, the initial velocity and the acceleration and the final velocity. And we're looking for, what are we looking for? The stopping distance. So we're looking for d. So you can use the same formula as before, right? If you look at our formula sheet, we've got Vf squared, what's the final velocity squared? 0 squared equals 20 squared plus 2 times the acceleration, it's negative 7, times the distance, which is what we're looking for. So that equals, what's the distance? Distance equals negative 20 squared over 2 times negative 7. So what's that? That's about 28.57. So you just add this to this one over here, and that'll be your answer. Alright, just solving in the formulas. Okay, what about this next one? Okay. John sees a flower pot pass a 2-meter high window of his 5th floor apartment in a tenth of a second. The distance between floors is 4 meters. Assume the pot fell from rest and G equals 10. The pot fell from a few options. Okay, let's go down. We can draw a quick, simple diagram. So you can imagine you're in the apartment. Okay, bro, come on. Right, this is the window. And you see the pot fall from the top to the bottom. It falls, the thing was 2 meters, and it falls in 0.1 seconds. So you can use the velocity average formula to find the average velocity, which is, what was it? It's, what am I doing? I don't know. Not sure. Because then you need the initial and final velocity, but you don't know the initial velocity here, and you don't know the final velocity. But anyways, the average velocity, it's gonna be, it travels 2 meters in 0.1 seconds, right? Speed, we're finding the speed. Speed equals distance over time. And 2 over 0.1, that equals 20. So our speed, our velocity is 20. Actually, our speed is 20. Our velocity would be negative 20 meters per second because we're traveling in the negative direction, traveling down. This is pretty much what we have. V equals negative 20 meters per second. We want to find how far it's traveled from the top to reach this point. And we know the initial velocity is 0, and they said gravity was 10. It's technically negative 10. Let's use that formula we used before, the one that has final velocity and initial velocity. So because we're looking for the distance, right? So final velocity, we've got a negative 20. So negative 20 squared equals the initial velocity 0 squared plus 2 times the acceleration. The acceleration was negative 10 times the distance. We're looking for the distance. So distance equals negative 20 squared over 2 times negative 10, and that equals what? 20 squared over 2 times negative 10, and that's about negative 20. So from the point of origin, it's traveled down 20 meters. And what does this formula give us? This formula gives us the distance it took for the pot to reach that speed of negative 20 meters per second. So it's traveled down 20 meters. We'll do 20 divided by 4 to determine the number of floors, and that's 5. So it's traveled down 5 floors. We're on the 5th floor. So 5 floors above us is 10. So the answer is C. Moving on. A woman on a bridge 75 meters high sees a raft floating at a constant speed on the river below. So we've got a river. We've got the river. And there's a woman up here. Bang. Bit of hair. And the bridge is 75 meters high. 75 meters. And there's a raft. There's a raft below. She's trying to hit the raft, and she drops a stone from rest. So she has this stone and she drops it down. And the raft, when she drops the stone, the raft is 7 meters away from the bottom of the bridge. So you can imagine the bridge casts a shadow. And the bridge is 7 meters away from the shadow. The stone hits the wall 4 meters in front of the raft. Okay, so here's 4 meters. Find the speed of the raft. So what do we know? We've got this distance here. All we really know is how far along the raft has traveled, right? So she dropped the stone, and the stone's right above the bridge, right? So that's where the raft was traveling towards. So at first it was 7 meters away, and then it was 4 meters away. So the distance traveled is 3 meters. So remember, speed equals distance over time. We've determined our distance to be 3 meters. What we're looking for now is our time. So what formula can we use? Let's think. We've got the initial velocity. We'll find the time in terms of the ball. The stone. What's the initial velocity of the stone? Vi equals 0. The final velocity, we don't know it. The acceleration, let's assume acceleration, so it's nice and easy. Acceleration is negative 10 due to gravity. We've got the distance, 75 meters. we'll use the distance equals initial velocity t plus half at squared. So distance is negative 75. We've traveled 75 meters down. The initial velocity is what? 0 times t plus half, what's acceleration? Negative 10 times t squared. So what's t? T equals 2 times 75, that's 150, over negative 10, and we take the square root of that. So I don't know why it does that, man. But anyways, it's square root 150 over 10, which is about t equals 3.87. So what's our speed? Our speed is 3 divided by that, which is 0.77 meters per second. And that's it.